Welcome everyone to this recording of a webinar in front of a live but muted audience. It's very nice that you chose this afternoon to join us, and I'll just say up front that we're recording this and putting the results on the website after no editing at all. So we should be careful what we say, because this will be with us for our grandchildren to watch, our grandchildren's grandchildren. But that doesn't make us any less excited. This is the second MONOCLE webinar focused on citizen science, Earth observation using satellites, and what this means for the future of an integrated environmental monitoring system. MONOCLE started in February this year and will run for 4 years. So we're at the start. We're mostly presenting plans, and we're appreciating all feedback to make sure that what we are going to work on is not something that has already been done or something that you would rather do with us. My slides are not advancing, so just if you could click on the PowerPoint presentation, just one mouse click should do it. There we go. So this is a series of webinars. We are doing the second one now. The first one you can find on our website, which was on the optical monitoring of the aquatic environment in general, focusing what the current challenges are and what opportunities this brings. Please have a look if you haven't already seen it. And if you're seeing the current webinar through the live recording, then you will see underneath the recording also a few useful links to skip forward if you don't care about what I'm currently saying, skip backward if you realize that it was worth hearing after all. And that's all up to you. And there will be a third webinar on the sustainability aspects of an observation network for environmental, for water quality monitoring, which we are planning for September. That date needs to be confirmed still. We have some field work to do this summer first. So what you'll hear from us, I'll first let you know who's around the table, and we'll then go through a series of slides from several of the speakers summarized as the citizen science contributions to Earth observation of water quality, and vice versa actually. We have a few of the success stories to show that this is a thing now. We have launched this survey about six to 8 weeks ago, from which we've collected several results to share, and we'll then focus increasingly on how we focus the MONOCLE project on new innovations and how these will be tested in the Freshwater Watch program. Throughout, if you want to start asking questions, please go ahead, click the Q&A box at the bottom. Jess will look at those questions. So that's Jess.
Hi.
Start with the introductions right away from somewhere in the middle. The MONOCLE consortium is quite large. We are not all represented here today, but from the MONOCLE project participants, we have got Earthwatch, the University of Leiden, and the Plymouth Marine Laboratory here. So far away in Italy, dialing in is Stephen Wazell, and you are the lead on the part of the Freshwater Watch program, if I get that right. Feel free to unmute yourself and correct me. That's most welcome, of course.
So far, so good, Stefan.
Thank you very much. That's a relief. Luisa Galgani at the University of Siena, you are joining us as part of the advisory board of MONOCLE, and you have a Freshwater Watch project running focused on plastics accumulation, I think, in the aquatic environment.
Yeah, that's correct. Yeah.
Thank you for joining us as well, all the way from Italy as well. Then dialing in from the Netherlands, from the University of Leiden, is Olivier Burgjaaf. Welcome, Olivier, as well. And you are developing the iSpecs, of which we will hear a little bit more in a moment. Next to me, do you want to introduce yourself? Because that, no?
Yeah, it will be a pleasure. Thanks.
Yes, Luigi.
Yeah, I'm Luigi Ceccaroni. I'm at Earthwatch, and I'm dealing mainly with the impact of citizen science in a variety of settings.
Yes, and you are the lead of the dissemination exploitation work package
in MONOCLE.
MONOCLE.
Yeah.
Jess is the most important person in MONOCLE.
True.
Jess Hurd is our communications work package leader and overall project manager. So welcome, Jess. Thanks for coming back from your long weekend. And I'm Stefan Simis, and I'm also very happy to be here. So let's get started. The sort of overall picture we're trying to paint in this webinar is that of water quality observation networks operating across multiple spatial and temporal scales. The icons there in the middle of the screen kind of show some of the focus we have, ranging from satellites to remotely operated aircraft, buoys, and of course what we're here to discuss today, the citizen science aspect. So what we want to know is, what is the way towards complementary integrated observations so that they would support validation of satellite imagery, but also support wider impacts of the integrated data streams that we know we can provide today. It's good to mention that satellites, of course, provide the essential global coverage, and nowadays this goes all the way from oceans up to rivers. But we're looking at a sort of limitation in the sense that satellites either provide the optical or the thermal data to work with, and not necessarily deep into the water column as well. A highly complementary way to work with satellites and in situ data is to have automated in situ systems, for example, buoys or data from ships or instruments mounted on poles. And these will be used to validate the satellite data. However, that is a relatively costly approach. And what this has resulted in is that there are still large gaps in the complementary data provision. So the question is, what can citizen science bring? And I'm going to, I think, skip to Stephen, is it? Yes, yeah. I'm going to skip to Stephen, because Stephen's going to tell us exactly why citizen science is the solution to everything.
Very good, and that's exactly was my opening line. It's a solution to everything. No, the idea of citizen science is to support scientists and researchers by gathering much higher frequency, higher spatial coverage than one or a group of scientists can do. So what we've seen in the Freshwater Watch is a global program. There's about 60 projects on every place on the planet except Antarctica at this point, and we're able to show that gathering high frequency data gathered by citizen scientists, which has some restrictions, but we're able to identify micro scale conditions that are exactly complementary to the macro scale information that you usually get from remote sensing. So whether that's water quality, so optical measurements about water color, sediment load, algal blooms type things, or even just the drivers of lots of problems of freshwater bodies, such as land use, land cover. Having microscale information gathered by citizen scientists is something that works perfectly together with information gathered by remote sensing. So we've done this in a few different projects, putting together this macro and micro, demonstrating how that actually works. The challenges there's a number of challenges with citizen science in gathering robust information, but working from a global platform, working from a consistent, robust methodology, it's easier to guarantee that a measurement taking on the Ganga in India and a measurement taking on the Zambezi in Zambia are taken in the same manner, and that we can use that information to determine what are the drivers. Some of the benefits of this are obviously that you can do things that aren't optical. So you can do things that are key to understanding optical conditions, such as nutrient measurements and other things. So it's highly complementary. If we were, if properly set up, it can gather information that will help understand the dynamics that we're seeing through water color measurements with remote sensing, or algal blooms, or just sediment dynamics. So it's a tool with challenges, and we'll get to those challenges in a second. Probably Luigi, you have some information to add to that now. Maybe go to the next slide.
Yeah, sorry, I was ahead of you there.
Yeah, I mean, building on what you just said, Steven, we can say that citizen science can be another element in water monitoring, or in general in environmental monitoring, that can create an environment with enough information to be able to provide strong, robust decision support tools to the decision makers and the policy makers. And I think that it's important. I mean, we heard about this many times, but it's important to see that there are already examples which are real, which can be used by anybody, and which can inspire and support new development. So in the previous slide, we have seen a couple of strong papers supporting what Stephen was saying. And here I would like to show you an example coming, in this case, from the States, in which the integration of different sources of data coming from remote sensing, in situ high resolution observing systems, and field programs which include the citizens, this kind of integration of data can really give us the information at a point in which we can know the situation, in this case, of the health of the beaches almost in real time, and even to predict this, the state of the water in the following day. So we are going from a situation in which we can decide about the state of a beach only with 1 day of delay, to a situation in which we can in real time say, now it's possible to swim, now it's not possible, now there is this bacterial contamination, and it's better to take precautions. So let's say that the integration of all this data can really provide a powerful tool for decision makers. And the only thing that I wanted to add is that if we have this in place, then we are also responsible for maintaining this in place, because if people start relying on this kind of information in near real time, then we need an infrastructure that is robust enough to be able to maintain this flux of information all the time.
Yeah, it's definitely where water quality remote sensing has come always from the premise of an early warning system. But the early warning system is usually hampered by, for example, cloud cover.
All right.
Or the fact that it takes 24 hours to get the satellite image as well. So I think that's what you're showing here, the complementarity again. Oh, go to the next one.
Yeah, let's go to the next one. And I would like to...
Could I just jump in for a second, Luigi?
Yeah.
One of the things that is really been evidenced by the last 2 years of citizen science, in particular, the things that are going on in the Freshwater Watch is we can run an event, let's say, where we have hundreds of citizen scientists going out across a catchment, looking at the small tributaries, the large tributaries, and gathering some really fundamental information that is then part of capturing that real-time episode or that real-time event. That can feed into that can be very complementary, can integrate well with the remote sensing aspect. So having a type of freshwater blitz out there, it just went on 3 weeks ago in Ravenna. There's one a month ago in the UK and Sweden. This kind of activity from citizen scientists can really map out an entire territory in an afternoon or in 24 hours, that then can feed into the policymakers and the people studying the territory using remote sensing to identify exactly what's happening on the micro scale.
Yeah. Steven, do you have anything to add on the slide that we are showing at the moment, or?
Well, yeah, one of the things that we've been able to, that we're talking more and more about, is working with working with particular local areas, whether it's a reserve in Tanzania or an area in reservoirs around Sao Paulo, to be able to understand exactly what's going on through citizen science. And then with that, and all those projects are sponsored by local water authorities, local decision makers who want to know better what's exactly going on, so that to see the impact of their actions the mix between remote sensing and citizen science is a powerful tool.
Right. Can we go to the next one?
Yes, I will. I was just thinking how important it is to provide this sort of camouflage clothing while you go out into this field campaign.
Can I just ask a question?
Yeah.
Do you have any good examples of recently in Earthwatch, for example, on how those citizen scientist data have actually driven policy change or policy decisions somehow in some places? Or how long do you think those kind of data need before they can take it into account and really drive some decisional change? Or
Well, that's a good question, Louisa. And there's many examples. One very recent example is this this blitz that went on in Ravenna in Italy, following that that measurement, in which there were, I think, about 110 people who participated, taking measurements through a relatively small area, but evidencing an impact of elevated phosphate concentrations. The local water authority is now acting to using that baseline map, that photograph essentially made by citizen scientists, to try to understand what those impacts, where that's coming from. And then on a post, and then what will happen is, in another example, is in the UK, in the Thames catchment, the water authority, or in this case the water company, is acting to reduce point source pollution related to phosphate concentrations, and they're using citizen scientists to validate the effects of that. So it's a tool that, if managed well and done in a robust manner, can help people, decision makers, understand the benefit of what they've done, as well as to identify, well, what's happening here, and where's the problem coming from. So it's all these projects have to be, a proper project should be run with a scientific hypothesis behind it, but with decision makers supporting and being the stakeholders in the actual activity.
yeah.
Excellent. We've jumped right in. That's perfect. Couple more slides maybe, and forward. Yes. Have I skipped one?
No, that's
Was that the last one? It's somehow very slow to respond. Okay.
So if you guys want to read about some of these, for example, we've shown that, we showed a couple years back actually, that citizen scientists acquired information on watercolor, and citizen scientists information acquired on, for example, turbidity or Secchi measurements, Secchi depth or Secchi tube measurements, has a very strong correlation with the actual phytoplankton density. So understanding, being about in multiple places, measuring rather simple information, but information that limnologists have used for 150 years essentially, we citizens can actually predict the advent or the increase in phytoplankton density that will eventually lead to a phytoplankton bloom. And the same thing goes with sediment at the mouths of rivers that going into large lakes or into the coast. We can capture that at different points along a river or along a lake shore, and that will help us understand what's happening on a larger scale throughout the catchment or throughout a particular lake or coastal area.
And those lakes and coastal areas, they can in turn be mapped with satellite remote sensors particularly. That is then a relatively low cost per observation. And I think the question we're now facing is, have we come to the point that we can start to integrate these observation data streams? Have we got everything in place, or is there a need for projects like MONOCLE to innovate a bit further? So I think I'll take that to what we got out of our survey. This is actually a question that was also featured in the first webinar, but I've reorganized it a little bit. So we had currently over 140 people who are actively measuring or sampling in the field respond to this survey. And the first thing is that what is absolutely the most important set of parameters is the nutrient status, the biological oxygen demand or chemical oxygen demand, and then things like chlorophyll and temperature and turbidity that we can also observe from space. I've just color-coded here the elements that can also be observed in situ, and in particular for which there are kits already available to include in citizen science frameworks. So you can see that there is overall, there is this high demand, and there's good overlap between the observation mechanisms. Just one thing to mention is that nobody's measuring watercolor or reflectance, as we like to call it. It's the amount of sunlight reflected, describing the color of water, and therefore enabling us to interpret satellite imagery in terms of what is in the water. And that is the most important measurement to support remote sensing of water quality, to make that link between the satellite observation and the observation on the ground. So there's no clear incentive, it seems, for practitioners to include that currently. And that is actually exactly what we need. So we've already learned that indeed that is missing. We also asked how important do you consider different platforms, among which there were some citizen science flavored possibilities. You see that overall there's quite strong support for anything we measured, going from sampling from the shore, near the shore, or equipping buoys with sensors, all the way to using drones to capture imagery of the water. Interestingly, in the middle though, you see that the perception of the value of citizens taking measurements or sampling water is a lot more mixed, and equally involving drones that are flown by hobbyists with relatively simple, cheap cameras on board, that we don't really see that happening. So if we do believe that there's an opportunity here, then there is a continued need to demonstrate this. And the opportunities definitely exist in the environments that are reachable by citizens. Then we asked specifically about citizen science inputs, where we think that citizen science can really contribute to the observation network, so to say. And then again, you see maybe the obvious ones are large-scale campaigns, expanding the spatiotemporal coverage of what we can do with national monitoring programs and remote sensing as well, that they are really well supported. So that role is very clearly seen by all practitioners. When it becomes a little bit more skeptical, I think we've had a lot of scientists respond here, is when it comes to maintaining in situ sensors or calibrating in situ sensors. And actually, some of us do believe that there's an opportunity there for reviewing protocols on how we keep sensors in the field. Because if this works, it could be a way to really lower the cost of automated stations in the end. Also, I've put an exclamation mark now next to the item saying that we would use drones to capture water quality or pollution. Suddenly there's a lot of support for citizens taking part in this. So maybe the difference with the previous question is that, yes, we see hobbyists taking part in collecting information, but maybe not with the cheapest of equipment. So we can expect support for whatever we want to demonstrate. The other dimension in coming up with a successful implementation is cost. And discussed in the last webinar, and in another question in the survey, was what do you tend to spend on sensors that are important for you to measure the water quality parameters that are most important, say nutrients or oxygen. And we see that there's about 10% of the budget available to equip citizens with a single sensor. So that is a big jump in terms of the technology that we need to develop, that it actually needs to be low cost to be supported. And when you look at the distribution of answers compared to whether an organization would buy sensors for a group of citizens, or whether the citizens would be expected to invest in this technology themselves, there's an even bigger shift towards low pricing. And in the panel on the right, we then ask the same question, but regarding the annual maintenance. And you see that this has again jumped by a factor 10, basically, towards 10 euros per annual maintenance. So really, there is not the expectation that there's budget to, at the same time, scale up the spatiotemporal coverage and keep well-maintained sensors in the field. So we've got to get really clever in terms of networks that integrate these data sources so that we can start identifying which measurements are good and which ones are spurious. Then we put a few existing solutions on the screen, and we asked which ones of these are you actually familiar with. And of course, the benchmark here is the SECI disk, because it's been around 150 years, and they don't break. They are fairly easy to operate, and you don't require a lot of training to take a good SECI disk measurement. And then there are some of the newer initiatives, including one that's actually more of a hydrological measure. These are handheld systems or easily deployed by one or two persons, including the Eye on Water, but also, as colleagues in the USA and Canada mostly brought up, the HydroColor app, very similar principle, to measure the color of water on a smartphone. And that could be that link directly to satellite imagery that we want to collect in the field. But the uptake of those is probably limited by by marketing at the moment, and maybe success stories. So just to put a few of these existing principles together, I mean, these are examples of where a solution is provided. And by a solution, I mean that there is a theory that holds, there is an implementation that works at relatively low cost, although that depends on what platform you're looking at. So bottom left is a smartphone, bottom right is actually a much more costly kit, but it can be installed on a yacht. And I suppose if you can afford a yacht, you might be able to afford those sensors, whereas if you can afford a smartphone, you might not afford a yacht and fancy sensors. And finally, there's a use case. And that brings me to the next slide. The use case shows that the implementation works and that there is uptake. So one part of that is scientific validation. The top there shows that the red channel from the smartphone corresponds to turbidity and therefore light availability in the water. The bottom case is from the SECI disk dip-in project, which shows that trends are becoming visible after these more than 40,000 observations have come in over many, many lakes. And these trends show in some lakes an improvement in transparency, and in other lakes a downward trend. That is the use case. That is what you can bring to policymakers to say, look, fund this initiative. It makes sense. It's providing us information that would be much more costly or impossible to collect otherwise. In MONOCLE, we are taking up some existing solutions and innovating these further. The first one is the K-Duino, and this is at a price point of roughly 150 euros, which includes a microcontroller and a string of light sensors, which are the yellow tags that you see there dangling from the buoy. And that is not a fancy oceanographic buoy. That is a canister that has shown a very successful way to get, for example, schools and educational programs involved in taking light measurements in situ. And these sort of light measurements are actually, from research cruises, still the most scarce data sets in satellite validation. So these have potentially enormous value. And the other thing to say about that is, we're trying to innovate this sensor to also start saying something about vertical stratification. If there's an accumulation of material near the surface, that kind of invalidates a satellite measurement of the same water surface, because we'll have to assume the water's fully mixed. So that is another way to look at the same water body from different scales. I'm going to invite Olivier to talk about an even cheaper solution to look at air and water together. Go ahead, Olivier.
Thank you, Stefan. Yes, so within MONOCLE, Leiden University is developing iSpecs. Some of you may already be familiar with iSpecs because we already did a campaign with it a few years ago. What you see here is how it's used. So it's just a small smartphone add-on, just a piece of plastic essentially for the user that you can put on your iPhone to turn it into a spectropolarimeter. On the next slide, we have some results. Stefan?
Sorry?
Next slide. Yeah.
I was reading one of the questions.
That was seamless. Okay. So in 2013, 14, and 15, with iSpecs, we did a campaign for measuring aerosols. So you see here the aerosol optical thickness. That's a measure for the air quality, essentially, over the Netherlands. On the left, as measured by iSpecs, volunteers. So every data point, or every dot here is a data point. Every dot here represents one citizen scientist. There's about 3,000 in total. And then on the right, we have MODIS, which is a satellite measuring the same aerosol optical thickness at the same time. And you can see that there's a very good, that the two images are very similar. So you see that the ISPEX data is of very high quality. And as a fun fact, we actually managed to get every one of these 3,000 volunteers as a co-author on this paper. So that's what we've done for air quality. Now on the next slide, Stefan, thank you. We have the measurement protocol of ISPEX. So what we're developing now is a way to use it for water quality as well. So the idea is still it will be a smartphone add-on. You have a small plastic add-on, you put it on your phone. There's an app that tells you if it's mounted right. Then you just take some pictures of your local river or a local lake or whatever you want. And then it gets data and it analyzes the data for you. We're not yet sure what shape the add-on will have or how the calibration will be done, stuff like that. We're still developing it, but this is the basic idea. It's just something you put in your smartphone and you take pictures. But then finally on the next slide, yes, thank you. This is the kind of data you get from ISPEX. So on the top right, you see an ISPEX image of the sun. So you see we have a full spectrum, not just RGB. We have, for every wavelength, we get the intensity, which allows us to do much more than just color measurements, because we can see specific substances in the water like chlorophyll. We can validate satellite data with this as well, because we can sort of transform this data into what a satellite would see. Now on the bottom right, you have the image of the sky. So this is using polarized light. The idea behind ISPEX is that it encodes polarization into the spectrum. So the dark bands you see essentially tell you that this light source has a lot of polarization in it. Now in this case, that's a measure for the amount of aerosols in the air. But for example, when you're looking at water, you get polarization from reflections. So we can use this technology to determine which light is coming from inside the water and which is a surface reflection. Because reflections are a big difficulty with remote sensing of water quality. It also allows us to do atmospheric corrections very easily, because we can measure what light is coming from the air and what is coming from the water. Finally, what we're innovating is the calibration. So smartphone cameras are obviously not for science, they're for making pretty pictures of your cat or your dog. But they can be used for science. They are just good cameras, but the software doesn't want you to use them for science. So we have to develop some methods to calibrate the sensors, which I'm now working on. I think that's it for ISPEX. So back to you, Stefan.
Thank you very much, Olivier. I think it's brilliant that the selling point here is that a little bit of extra hardware maximizes the potential of what's already in the smartphone, and that makes it worthwhile. So yes, in the last webinar, we showed a number of complementary approaches which are not so much focused on the citizen science market. Just to summarize, what is then included in MONOCLE is that we have these innovative technologies that we're developing. We try to achieve a high degree of sensor automation to really capture every satellite overpass at the same time. And then the role of the citizen scientist innovations is to do the gap filling using low-cost sensors. In addition to that, we want to review what is possible in terms of sensor maintenance, calibration protocols on site to lower the cost and to minimize the amount of time that sensors might be away for calibration. All of that creates a need for the real-time integration of data sources, for which in turn we need to maybe overhaul some of the data sharing principles and data sharing methods. Nobody wants to steal away data from the owner or creator, but the owner or creator might be very okay with certain uses of the data in near real time. And currently it's the other way around, that most data is collected and made available within maybe a year. And then the relevance for remote sensing may be much less. So these approaches need to be tested, and for that we have both a plan to integrate data from multiple sources and at multiple scales into existing Earth observation services, such as, for example, the Copernicus Global Land water quality that we run here from Plymouth, but also the citizen science projects. And that is actually the main reason that we are partnered up in this project with Earthwatch, because you've got this worldwide network with relatively established, I'm trying to avoid the word tame, but now I used it, observation networks. It's just worth repeating that makes MONOCLE not so much a typical citizen science project trying to get a new group of citizens together to tackle a new challenge or evidence environmental change. We have that aspect here to test the innovative technology. I think that brings us to Luigi, I think, to wrap things up a little bit.
Yeah, let's say that even if we are not a typical citizen science project, we, in certain part of the project, we deal with citizens, we deal with situations in which we need to research and study how to bring this technology in the right way to the people. And of course, we need to think about the limitations that are related to involving citizens into science. And especially when we have to deal with complex processes like the ones that are typical of the optically complex water that we try to monitor. We need sometimes a lot of observation from the citizens. And getting a lot of observation from the citizens needs a strategy to maintain a critical mass of them during time. And this is one of the tricky things, because maintaining this critical mass is not straightforward, and it needs a continuous effort of engagement and reaching out to new communities. Also, related to this, there is the fact that for citizens to stay involved, they need really to be rewarded on the one hand about what they're doing, but also to really be convinced that their contribution is important for science and for society. So there is a whole part of our work that is related to educate and communicating to people about these issues. And also, it is important, and it's always a challenge to find the right use cases, because everything we do, everything we monitor is differently important depending on the audience, depending on the people involved, depending on the actors. So we need to really find use cases that are relevant for not only for the scientists, but also for the communities of citizens that we work with. And of course, if we succeed in doing this, if we reach a lot of people, if we have a network that covers, let's say, possibly all the globe, then our impact on policy, our impact on research, of course, is much greater.
So,
may I ask a question on that slide? Sorry.
Please.
Yes.
Yeah, quick question. So, on a practical, let's say, practically, do you have a plan in MONOCLE? I mean, on how to measure effectively the impacts? I mean, besides the testing of the technology with existing networks of both citizens and, citizen volunteers and scientists, do you have a plan on how to evaluate the time committed, for example, in terms of impact on MONOCLE? People reached, number of scientists and citizens that are involved or engaged or activated, let's say. so that once the project and the technology is available, it will be basically ready to be launched? I mean, do you also plan some kind of, I don't know, an example, surveys, or work together with some social scientists on how to effectively say, okay, we have the technology, and when it will be available for everybody, it will work, because we also tested an implementation plan or the impact of the technology?
Thank you. Kind of. So the project's very much technology innovation focused. So that is a potential weak point, but we're still at the beginning. So I think you've just volunteered yourself to review our sort of key performance indicators that we're currently drafting.
Okay.
There is, however, we did look ahead a little bit. So I said we're using these established citizen science initiatives to try out some new technology, because we don't want to ruin it for the PI of those projects by presenting something that doesn't work yet. But we do need to test to improve, to make sure that it does work for everyone. And then things like age and gender and cultural background play quite strongly into these performance metrics. But we also thought, well, that can't be all. So we also need to have a fresh case. And that should be a fresh case, preferentially in a place where there's not already something like this going on. So our colleagues in Tanzania at Teferi have started to set up a new, from the ground, a new citizen science observatory around Lake Tanganyika, starting with the freshwater watch kit. But basically within a year, they will start receiving, for example, the ISPEX prototypes. And that will be a way for us to study whether it works or whether nobody knows why we want this, for example. And then we have to work a lot harder on making that use case visible. Does that answer your question?
Yeah. Thank you.
And thank you for volunteering again.
Well, I think Luisa asked a very complex question. And when you talk about the impact of citizen science, you can answer in very different ways. And as Stefan was saying, maybe MONOCLE is not the main project answering this question, but we know that there are other projects that are running and other projects that will run in the near future that will have as aim just measuring and quantifying the impact on citizen science. There was a call by the European Commission last April explicitly mentioning the impact of citizen science in the project that needed to be submitted. So I'm sure that later this year we will have a strong project, this multi-million EC funded projects, trying to give a quantified answer to what you were asking. We will contribute a little bit.
Okay, thank you.
If you're writing one, good luck.
But I'm saying that quantifying impact is a complex question also because, for example, in the slide that you can see now, you have a few details about Freshwater Watch. So, I mean, saying that we have over 10,000 participants, 20,000 data sets, and monitoring over 3,000 lakes, streams, and ponds, I mean, in 40 countries. I mean, that's also is an impact, but this is not really an impact that you can quantify in terms of societal challenges or SDGs. This is just the output data coming from Freshwater Watch. Of course, a strong effort is needed to translate this into something that people can really feel as an improvement of their quality of life or their access to environmental information, or in general, something that can be aligned with indicators that are generally used for this kind of domains.
And it is maybe a direct impact both on policy and the environment as well. If you look outside this frame, where the water quality is more of a slowly evolving variable to look at. But if you think about the use and the acceptance of single-use plastics, some countries are now just steaming ahead with both grassroots initiatives and politicians just about being able to pass a law to stay up to date with the changed public opinion that single-use plastics are no longer have a role in our lives. So maybe there is also a way that you can say that so many people willing to take an active role in monitoring also means that these people have connections in politics, perhaps, or a common voice to influence management, to show where the money should go. But it is hidden.
Yeah, or at least it is not always possible to identify the sources of influence to policymakers, because we can have a big awareness among citizens, but you don't really know if that's the key role that was needed to change legislation about whatever. So, if you let me, because last week was the conference of the European Citizen Science Association, and a lot of people from all over the world. We were between 300 and 400 practitioners and project managers and plain citizens from all over the world gathered in Geneva. We came back with a few new ideas and a few maybe lessons learned about not just citizen science in general, but how we can better deal with the relation between the people and the researchers. How we can work on monitoring in a way that becomes more efficient if we involve the citizens. So here on the slide, you can see a very simplified representation of the complex relation between the citizens and the researchers. Thanks to Tos, who was actually presenting this in Geneva. Tos is another colleague from Earthwatch. And what you can see here is that a gradual approach to the engagement, to the involvement is needed. You cannot go from being unaware of science to be an ambassador of science just in one step. So that's why engagement and the social part of citizen science is so important, because you really need to go step by step and reach in time that can be, let's say, quantified sometimes in a few years. From you can go from a situation in which both the people and the scientists are not really aware or are not really engaged with science and with society, respectively, to people who can be considered ambassadors and joining forces collaborate on this relatively new field that is citizen science. So the main message is that we cannot forget about this social science element of the equation. And building on this, and again, trying to learn from sharing of experiences during the conference, let me just mention a couple of lessons that we brought back from the Citizen Science Conference. So an important one was that when we work together with the citizens, especially if we want to integrate complex technology into the way of working of the citizens, we really need to adapt to local culture, in the sense that especially if we work in the global south, and we have experience, for example, as Stephen was mentioning, in Africa, we cannot just use or reuse the methodologies and the approach that we are using in Europe, but we really need to understand what are the needs, what are the interests, what is the stage of integration of citizen science in society, to be able to provide a technology that is really the one that is needed in that point in time for that societies. So we really need to take that into account. And another important point is that we should communicate the importance of science, in the sense that when citizens are engaged in scientific activities, one of the best results of this collaboration is that they understand better the importance of science in society. And when they have to lobby, when they have to interact with policymakers, they can do that in a different way, taking into account that they know that scientific monitoring, scientific intervention are needed and are important, something that usually is not the case. And a classical example is intervention on landscape, when the city needs to change the landscape because of some risk about, for example, flooding or other environmental risks. Sometimes the intervention goes against what is the visual pleasure of the landscape, and citizens can react in a way that is not the one that they have if they have the scientific background to understand the importance of this intervention. And finally, another couple of points that are related to recommendation coming from the ECSA conference. One is that there is a general vision that information in general, but information especially in citizen science, should be made open access as much as possible. But of course, taking into account what open access means and the consequences for all the actors involved. And another point is the importance of the settings that we use when we have to interact with citizens. Because when researchers who are used to a certain setting for disseminate their results, their methods, when they work together and hand in hand with the citizens, they need to do it first of all face-to-face, and then in a way that is informative but also informal enough for the message to be transmitted in an efficient way.
We will be sharing our failures in 4 years, right?
Exactly.
Stay tuned.
No, we can share them before.
So this is bringing it back to not what citizen science can do for remote sensing, but actually how the remote sensing component in the network could contribute to an integral network where the citizen scientist starts to benefit. Because that is the main engagement challenge here, isn't it?
Exactly. Yes, because I mean, citizens stay engaged if, as we said before, if there is a reward, if they recognize that their role is important. And so here we are presenting some ideas about, the other way around, why remote sensing really can add value to citizen science. And this can happen in a lot of ways, but we selected a few ones that we think are especially important and relevant in the MONOCLE setting. So first of all, let's say that in general, the idea is that when we offer citizens new tools based on remote sensing or other high resolution sensing, these tools should maximize the participation of the citizen. And this can happen in at least a few ways. For example, we can provide notifications and alerts about something that is happening. So for example, if we know about a satellite overpass, if we know about some episodic event, then we can engage citizens in what we call opportunistic sampling. So we can say, okay, there is something going on. There is a satellite that is passing over you. So that's the best moment to go out and get a sample, because this will be the best possible validation of that satellite data. or this will be a critical moment in which we need the data to understand that natural process. And related to that, we can use this context information coming from a variety of sources to change the way in which the citizen science activities are managed. So, and in particular, the frequency, because sometimes you are in a situation in which you don't really need a lot of contribution from the citizens with respect to data collection, because this data collection is already well covered by other sources, while you might find yourself in a situation in which you are in a data poor region, and in that case, you should increase the frequency of the sampling by the citizens. So trying to put all this together, we can find a situation in which the citizens are much more engaged because they understand that their input, their contribution is especially valuable in that particular context, and not that they are just collecting data and they don't know if they are useful or not. So further opportunities about the contribution of remote sensing to the citizen science are, on the one hand, that the new technology that we are developing, all these things that we were talking about before, they can really be so efficient in data collection that sometimes the contribution of the citizen as a human sensor is really not important anymore. So we need to understand that the importance of citizen science is not just having people collecting data. That's, of course, is important, but that's not the main point, because
I think the point there is that the first 100 in situ measurements are really important to validate the satellite approach. Mm-hmm. But the next 1,000 are much less important.
Exactly.
So if you've got your 100 quota for the day, you might as well say, you know, why don't you focus on this experiment instead of the standard observation that we need, the physical measurement that we need. Go count some plants instead.
Exactly. Participate in the program, but not just as a sensor, but maybe studying the interaction among components. Bringing new ideas about the project itself. So let's say that having this higher contribution of technology, higher contribution of remote sensing, we can take the boring work out of the citizens and involve them in ways that are much more pleasant or satisfying for them to stay engaged. Yeah. And the other point was that, of course, if we have satellites data overlapping citizens' data in time and space, we can then have this validation in double direction. We can, I mean, the typical case is that in situ citizens' data are used to validate satellite data, but because sometimes citizens' data are kind of not very accurate. They have a lot of variability. We have some data that are really directly wrong. We can use the satellite data to validate or at least to make consistent the data coming from the citizens. Yeah. And as a last point, we can also say that satellite data can be useful when you have to start a program in, for example, in the Global South, in a place in which you really have a limited amount of data available and in which you have a really limited opportunity to create a citizen science program because you don't have the right educators, you don't have the right setting, you don't have the right communities. So you can start up with a lot of data coming from remote sensing, and so you have the basis for them developing citizen science in a second.
That is the concept of the data revolution that we need to meet the Sustainable Development Goals. First, make a lot more data available more widely globally, and then the impact will hopefully follow.
Exactly that.
I think I can take this back. So I see that some of our listeners have, I'll just put this up as final thoughts.
Yeah.
I see that a few of our listeners have been using the chat window and the Q&A window. Are the questions visible to everyone already?
They will be when I...
Okay, yeah, I would just say share them, yeah. But are they visible? If you click there,
yeah.
Okay. And the other ones as well, I suppose.
Well, there were a few interesting questions that we can...
So rather than us doing much more to talking, I would like to encourage our overseas panelists to unmute and take any question that may come your way or may not. This is a really good moment to take on a few more questions. My eyes are not so good, I can see them, so rely on Jess to pick one.
Well, there's the first question about asking for sort of us to discuss and a bit of advice on how to plan citizen science campaigns and the timing of them.
I can add a little bit. That's a question from Mariana, right?
Yeah.
Well, we've experimented with both. So in some cases, it's useful to have a rather not rigid, but a fixed frequency and sites which citizen scientists can go to, and that can be more robust from the information per measurement or per effort of citizen science effort. But it, as Luigi was just saying, it needs to be engaging, it needs to be fun. So what we're finding is people stay engaged longer if they choose their own sites. So if you give them the frame of the term of reference that we're looking at this, so it needs to be related to this, and then they choose their places, their measurement areas, then they're likely to do it more frequently. If there is the possibility of organizing it in a slightly more structured manner, that's helpful. But as Mariana was saying, that requires more time from the scientist and from the organizational point of view. The nice part about citizen science is if you've got a platform that works, you can give citizens the idea of what is your hypothesis you're trying to prove, and what are you exactly looking to do, and they come up with very good suggestions themselves. So they'll usually go to where they're supposed to go. And of course, the strength of citizen science is you don't base it on 10 measurements, but you base it on 200 measurements. So you're getting a larger geographic coverage than you normally would. So, but excellent question from Mariana.
If I may add on this, it is also true that in terms of logistics, when you are planning for surveys every certain amount of time, you really need to have somebody managing everything. So making sure that people are going sampling on that specified time frame, because you are relying on those data. So you always need somebody to make sure to contact all the volunteers, remind them that we need data for that period. Even if they do it, let's say 5 or 6 times per year, you need a more. So it would be a longer term involvement from both the scientists and the volunteers, while when you have one sampling with a lot of people doing it, you need more time from the scientists, for example, to plan and prepare it, but then it will just be a one-time event. On the other side, you need to plan for a longer term activity of both scientists and citizens.
So, I mean, that face-to-face approach and that personal approach has come up a couple of times, and it was actually in the survey results as well, just not featured today. And I wonder, is there also an element of automation there to make it easier for the scientists to send out friendly reminders and to respond directly to, if 1,000 measurements have just come in, that you can send these people a message saying, this is amazing, keep up the good work. Today is Measure Your Fish Day. So I don't know if anything already exists or that there's really an opportunity to develop some tools there as well.
Yeah.
Yeah, there is. I mean, there is through all of these different citizen science platforms way to feedback and the element of gamification. Who's got the most samples? Who got the but as long as it people, you said the scientist, the face-to-face element, but it's that's absolutely true. We've seen throughout these projects the places that have the most energized, the most most interesting scientists are the ones that have very long-term activities. For example, the project that Louisa is running has these 30 or 40 people that just, you can't turn them off. So that means that's a credit to Luisa's energy in doing it. And we had a big project in Brazil that was generally, it was the Brazilians went completely crazy. Couldn't turn them off. All they wanted to do was sample, except when there was a World Cup, and then they disappeared. But beyond the World Cup, they were, and that was a tribute to the fact that the PI was super energetic and fed back to them every time it was time to measurement. The next day there was, this is what you've seen, and this is what your colleague across the river, across whatever was doing as well. So the power of the social element and all this is very fundamental. But at the same time, it's the mass picture that helps the scientist arrive at the understanding, or the policymaker or the water agency arrive at the understanding, and having complementary information from remote sensing, or having that same in situ sensor in one or two places, having that information feed back to the citizen scientist makes it all that much more interesting and engaging. So that's the direction we need to go in, so that we're not sitting in different boxes, but the boxes are, the information is flowing back and forth.
Clear, I think that, lots of trial and error needed there still, I think. Engagement, getting free data is our work. That's the main message, I think. So let's change tack. That was, we can talk about engagement all day, I think.
We have a question about the role of citizens in the calibration efforts and maintenance of in situ sensors, and how we are going to try and do that. What are our thoughts on that?
That is a question from anonymous attendee, isn't it? Yes. Yeah, that's a very good one. It really depends on what sort of calibration is needed. And then we can still separate absolute calibrations and relative calibrations. Say, often we use a light sensor in some capacity, either in the water or by looking at the water or looking at the sun. And this light sensor is in need of absolute calibration only if we need to really know the intensity of light. If we need to know the intensity of light of a target relative to some other target, the calibration becomes a lot less dependent on a laboratory facility, for example. So we're thinking of protocols where in the field using, say, a kit of a highly reflective panel can be used to take a measurement of of this known target while it's exposed to sunlight. And by also taking a measurement of the atmosphere, we know how much sunlight there ought to be arriving at that target. So then we're using a model of sunlight and location and time of day and a relative calibration. And that may well be enough to decide this sensor is still operating as well as it did yesterday or last week. Or we detect a sudden change, and then we need to investigate further or just send out a new kit. So those are the sort of principles we're currently toying with. There are many other ways possible. If you think about a fluorescence sensor, for example, there are substances you can buy in the supermarket, fizzy drinks, that have a very well-described fluorescence profile, and these recipes are perfectly stable over time. So you don't necessarily need a lab-produced chemical agent to do this calibration. You may just be able to use a recipe that's already pre-mixed and available globally, basically. I won't use any brand names here, but yeah, those are the sort of directions we're thinking about to reduce the cost. And another important element is simply having multiple sensors in one another's vicinity can tell us whether there is one that is clearly off. And that would be the most simple way, but it requires that density of observation data taken either at the same time, or, for example, all taking place while there is a satellite overpass. And then we use the satellite as the calibration benchmark, if we can. But currently more questions than answers there, so it's a very valid question. Any others?
Yes, we have a further question about if we'll be aiming for remote sense data to be validated through citizen science activities at a local or global kind of level.
Okay, that is a small question with a big answer, so I'll try to keep it quite small as well. The validation would always be local, but the algorithms that we use to interpret satellite data, they are more global. So if we understand from this global observation what type of water body, for example, we're looking at, then that local validation tells us also whether the satellite approach is locally valid in other locales, in other locations. So that means that as a validation measurement taken in one country could also validate the satellite approach in another place in the world, maybe on the same day or the next day, but a similar water body. I hope that answers the question.
Yeah, it's related to the following one, I think.
Yes, there's a further question about how we're going to make validated remote sense data available to people, especially in countries which have less technological skills.
Okay, that is not really part of this project except for some test cases, but this data revolution is already going on. So I would recommend you to have a look at the, if you're interested in inland waters, the Copernicus Land Service, which has a number of descriptors for water bodies that are refreshed at periods ranging from daily to 10-day observations. And there you can basically find the state-of-the-art of satellite observations for your local water body or for a large water body nearby anyway. So this is starting up to become a freely available global service. These sort of services still need that validation, and that's what we're focusing on here. However, anytime anyone asks me, could you please add my lake to your data set and include it in that freely available archive, then the answer is always yes. Just tell us where and when, and it's even more interested if you also collect in situ data, because then we can also do the validation.
Stefan, just to throw another pebble in the pond, but if everyone looks at their, well, not everyone, everyone in England looks at their weather app every morning before they step out the door, because you never know what's going to happen. And on the weather app, there is a map at the end that shows essentially the last thing from the geostationary meteorological stations. It's not going to be too far down the line that all that information will be on your app, and even better, as you said, there could be one of the things that we're developing is a program that allows the scientists to communicate to the citizen scientists, saying, look at this area needs to have a measurement taken because it's been 6 months, or we have no information whatsoever, and that area that's lit up in red or lit up in orange or something will be, you get extra points, you get more, you get the satisfaction of being the first one to take a measurement there or something similar. So what you're laying out is, I don't think is that far in the future. Obviously doesn't necessarily have to be something of Monocle's high priority, but it would be nice to play with it a little bit to get that information back to the citizen scientists and something that they could look on their smartphone and see their impact. So.
Sure. Yeah, I think that's that regionalization of these data that are obtained globally is really not far away. And if we placed our priorities there now, it could be done within the year. I think that there's a longer delay when it comes to water quality data from these ocean color satellites. That's just because they're a bit more complex processing streams. We're talking about 24 hours still. It cannot be avoided really at the moment. Jess, how are we doing?
We have no further questions at the moment, but if anyone would like to pose any.
Well, we'll keep an eye on that, but we have kept everyone long enough, I think. If you joined us from anywhere west of us, and thanks for spending your Monday morning with us. If you're east of us, then much respect for still being awake and attentive. And this will go on our website. And we also have a link there to invite any further questions by email. So if you've watched this offline and you'd like to join the discussion or inform us about an ongoing initiative that we should be aware of, and that is very much appreciated. And we'll take that forward and maybe be in touch. I think stays quiet, so that's good. I'd like to thank our panelists from far, far away, Stephen, Olivier, and Louisa, for your contributions today, and Jess and Luigi for traveling all the way here from Oxford.
Thanks for hosting.
Yeah, a pleasure, as always. We're going to do some work, and we're going to have another one of these in autumn. Thank you very much. And
Thank you.
I should put the logo on, otherwise we don't get paid. Thank you, European Union, for the project funding, and the taxpayers for supporting the EU.
Okay, have a good one.
Thank
Thank you. Bye.
Bye.